Hey folks, welcome to this episode on metallic bonding and their properties. So what is a metallic bond? Well, it's formed between atoms of metallic elements. So for example, copper, sodium, magnesium, etc., etc. What metals do when they're in this kind of bond is that they ionize into cations. Remember that they have low ionization energy, so the ability to remove that electron is really, really small, or it's very easy. The amount of energy that they need is relatively small. Now, especially when we get into the larger elements, the larger metals, for example, if we get into rubidium, strontium, for example, the ionization energy is even lower. So what happens is the electrons, the valence electrons, kind of leave their atoms and kind of move into this space in between these atoms. When they leave, again, they form cations. Now, when we're talking about, for example, if we look at lithium, where lithium has 2 electrons in the first shell and 1 outer shell, this electron, the outer electron, the valence one, will leave, still having these 2 electrons here and the 3 protons in the middle. So it will be a positive charge. So this electron is free to move around wherever it needs to, and it kind of moves all in between these different things. It's not really bound to any one atom. And what we call them is we call them delocalized electrons. They're not local anymore. They're in the middle, in the mix between all these individual cations, and it can move around this as any kind of pattern, and like this, whatever. Okay, and it keeps going, and it forms this kind of like glue, a negative glue for positive cations. Okay? And so we call this a sea of electrons. Again, they don't belong to any one positive ion. They're free to move, and that's really why their metals have some very interesting properties. Depending on, for example, the type of ion, you can have a 2+ or 1+, depending on how much it loses, and that will also change the properties of the metal. So here's a little picture of a delocalized electrons, a sea of electrons. You can see that each atom takes up a certain amount of space. There is some overlap here, and all these little electrons that have been delocalized are now leaving, are free to move around everywhere. And again, as they move around, they form this kind of cloud of negativity. And that cloud of negativity is acting like a glue for all of these positive ions. Okay, so all of these positive ions are now attracted to this negative sea, and you get this nice kind of sticking together material that we call a metal. Now, alloys are an interesting form. They're actually very, very important to our daily existence. They form a lot of different types of metals that we see. And what they are is a kind of combination of metals. Now, metals don't actually combine with other metals in that they actually change their properties. The individual atoms will mix with other atoms of a metal, and forming this kind of collection of metal atoms. They don't actually change, they don't actually react with one another, they just kind of exist in the same place. And this is called a solution, really, when we have different metals that are soluble into other metals. And the word that we're going to use there is miscible in their molten state. So once we melt them, we can mix them together, and we can form a different combination of metals. We can add more of metal A and less of metal B, or if we want to get some different properties, maybe metal B will be more than metal A. So it all depends on what properties we want, and that will dictate how much of each we have. A lot of things that we use, for example, steel, brass, bronze not so much anymore, and pewter not so much anymore, but steel and brass are very, very common metals that we use on a daily basis. And these are alloys. Some properties of metals: they have high melting points, they are dense, so that density comes from a huge amount of protons and neutrons within that little nucleus. They are good conductors of both heat and electricity. They're very lustrous, which means they're very shiny, and this has to do with how electrons hit the metal. And they're malleable and ductile. So if we look at our little kind of diagrams here about the properties of metal, in this first one over here, we're just looking at how this kind of sea of electrons work. Again, we have these electrons that move around and they form this kind of negative glue at which the cations are attracted to. And so we have this nice sheet of metal. In this case, it's Au, so it's gold. Nice piece of gold metal. Now in B, because the electrons are free to move, they're moving all over the place here. If we put on an electric field, so here's our negative side of our electric field and our positive, what we can actually do is we can create this charge differential, and the electrons will be able to move freely. And this is why they're good conductors of electricity. Likewise, because the electrons are able to move, they can move and pass on their kinetic energy to other atoms. So in this case here, we might charge up an electron in a sense, not really charge it up electrically, but charge it up in terms of increasing its kinetic energy, and starts passing it on to the different atoms. And you can see that as it goes on, these atoms start increasing in kinetic energy, aka they're good thermal conductors. Now the last part here is talking about ductility. So if it's ductile and malleable. So ductile means it can be pulled out into wires. Malleable, it can be hammered. Okay. Now, because again we have this negative sea of electrons, this negative glue in between these cations, if we put a stress or a force onto that piece of metal, what's going to happen is that these cations, because they're not really attached to one another, they're just kind of attracted and sitting in the sea of negative charge caused by these electrons, they can actually slip past one another. And if they can slip past one another and this kind of negative charge just redistributes to kind of buffer this, we could actually hammer it out into a certain shape, or if we keep pressing some force or we pull with some force, we can actually break them out and turn them into a thin wire. So again, metallic bonding is all about metals bonding with other metals, and it has to deal with the fact that they have low ionization energy and a low electronegativity. It's hard to remove those electrons. They don't want any electrons, so what they're going to do is they're going to form cations with this kind of sea of negative electrons around them that are delocalized. Again, delocalized meaning that they're not bonded to any one single cation. And because there is this negativity, the cations are attracted to that negativity, and this forms a kind of electron glue. Okay. So here are some of the properties that we have, and that's it for this episode. See you soon.